section 3.3, solving equations by multiplying and dividing. I guess I should make that capital. Oops. Whoa. Multiplying. Multiplying, dividing. Yesterday we did addition and subtraction. And how did we fare on that homework? Before I step over the next one, would anybody like to ask any questions before we move on over the undoing of addition and undoing of subtraction by doing the inverse operation? Inverse operation means an operation that is the inverse or the reverse of it, or as I like to say, undoing. So if you have something plus something, okay, something plus a variable, how do we get that variable by itself? Subtract. If we have a variable minus a number, how do we get that minus to go away? Yeah, you add. You have to add both sides by the addition property of equality. Now, what do you think has the relationship between multiplying and dividing that you see on your screen right now? Well, on my screen. What do you think their relationship is? Yeah. They are words. I don't think that your brain and your mouth just agreed with each other. What do you think the relationship of multiplication and division is? They can be switched, okay, yeah. Beautiful. They undo each other. And what was the vocab word I introduced you to yesterday in the notes and said just now? The inverse operation. The inverse operation. Because additive inverse means a positive integer and its additive inverse, which is a negative integer. Okay? This is just other operations. So let's see what makes sense to you first before we get going. Let's go 150. Yeah. And is somebody's birthday today? In here? No? Oh.
You should use a green color someday. So close enough.
Hey, you should use blue because it's the color of the sky.
White.
Okay, I'm writing. You are writing. So we're going to try negative 68 equals negative 4m. So m is being multiplied together with negative 4. To undo that, what do you think we need to do? Yeah. Divide by negative 4. Good. Divide by negative 4. However, this symbol here would be untrue unless we do something right now. We have to divide the other side as well by negative 4 because we have to keep those equal. So now we just have, since these guys cancel each other out, now we have just m on this side, and on the other side we have, what would that be? 40 plus 18. Well, I was doing the 22. Well, let's do how you can do this in your head. So off to the side, I'm doing 60 plus 8. 4 times 6 is 240. Plus I don't know. I just went back in time in my head to we're doing exponents with pre-algebra today. Okay, let's try that again, shall we? I'm thinking of how many times 4 goes into 68. And 4 times 10 is 40. And then it's 28 beyond then. So yeah. Now is it a positive or negative? Positive, because you have a division problem that has two negatives, which makes a positive number. So I circle that because I like circling answers. And here's what we just did. We just did the loud noise. And that's if you divide each side of an equation by the same non-zero number, the two sides remain equal. I'm going to make that prettier. Hold on. Is that prettier? That's not prettier. The division property of equality. If you divide each side of the equation by the same non-zero number, the two sides remain equal. For any integers, a, b, and c, none of those can be 0. For any integers, a, b, c. And the reason it says non-zero in the definition is because you cannot divide by 0. And once you're done writing, I'll explain that a little bit more. Are you? Where's your sticker?
Oh, my ID fell off my way. Now we're going like 6 of them.
Okay, the reason why it can't be 0 is because you cannot divide by 0. Okay? C cannot be 0. The reason you cannot divide by 0, I remember when I was a kid, I remember my teacher just saying this, is like, you can't divide by 0. The world would end. I'm like, okay, whatever. I didn't even care why, or I didn't remember why they actually said it. You can't. Because whenever you divide, what you're doing is you're putting a certain amount into equal groups. Do you agree that's what division is?
Yeah.
Okay, if you have whatever and you divide it by 6, you're putting them into 6 equal groups. You cannot take anything, you cannot take something and divide it into 0 groups. You can't, for example, I'm holding on to something. I can't take this something and put it into 0 groups. Okay, magic isn't real. All right?
Neither is witchcraft.
Yeah. Oh, I don't want to crush your beliefs at all. You want to believe in witchcraft? Have fun. Just don't hurt nobody. Okay? Let's do another example. D3, the Mighty Ducks. Now we have the variable is getting divided into 3 groups. And in order to find the inverse operation of division, we have to think to ourselves, boy, I am so smart. And you are all so smart that you would know that the inverse operation of multiplication is division. And the inverse operation of division is?
Multiplication.
Yeah. So I'm going to rewrite this. Well, no, I'm not. I'll just use a different pen color. So what I'm going to need to do is multiply this whole thing by, am I going to multiply by 3 or 3 over 3? Ooh. 3, because 3 over 3 is just 1. So I'm going to multiply this whole thing by 3, and here's a sibling that's getting their allowance tripled, and they're like, hey, that's not equal, that's not fair. So they're like, okay, you can have 3s, you can be multiplied by 3 as well. Yeah, the one who's like, wait, but I want my negative multiplied by 3, and the family's like, ha, you don't understand integers, you owe me more now. So now we have, on this side, that cancels each other out. So we have D on one side. And if I do something and I'm assuming that you guys are familiar with something, please stop me. Okay? Be like, I don't understand why you just did that. Please let me know. That's the biggest thing about improving your intelligence is being able to speak up when you don't know something. Being aware of what you don't know so you can learn it is a good thing. Then we have up here, negative 3 multiplied by 3. I have a negative and a positive. The amount of negatives for a product is odd, so we know it's going to be negative. And that's the answer. And what do you think the property that we just did is called?
Multiplication.
Yes. That's right. So I'm going to just take,
What if it's unequality?
that would be unethical.
Why?
Because-
Equal.
Because we like equality here. This is America.
But rich people aren't equal to us. I mean, they're rich.
All right. Copy. I'm going to just bring this down here, and it's going to be very similarly worded. Draw. I bet you know what the first word's going to be.
Multiplication. Oh, wow, you're right.
I wish I could do that on my own.
Yep.
Someday, kids. Someday. They said, I wish that I could manipulate my notes like that. And someday you can. Someday you'll be a real boy.
Unless the sun's glowing all the time. It's fine. It'll happen eventually.
Sorry, did I go before you were done writing?
Yes, you did. You did. I only got the property.
There we go. The multiplication property of equality. If you multiply each side of an equation by the same number, the two sides remain equal. For any integers, I'm going to say for any numbers now. For any numbers A, B, and C, where A equals B, A times C is equal to B times C. Sure. As having shoulder length hair isn't skater enough?
Yeah. That just looks like
Ah. One more time, the multiplication property of equality. If you multiply each side of an equation by the same number, the two sides remain equal. For any numbers A, B, and C, where A equals B, A times C is equal to B times C. It can. No. Yes.
So for the any numbers, how does that tie into the
How does it tie into what we're doing? That's a great question. That is a wonderful question. In this situation that we just did, how it applies to down here is we had A is equal to, let me rephrase that. The multiplication property of equality is just saying that as long as you're keeping both sides the same, it's all equal. I multiplied this side by 3 over here, and I multiplied this side by 3 with the intention of getting our variable by itself. And I'm able to do that by doing both sides of the equation. It's not just, I want to get d by itself, so I'm just going to multiply what's below it so it'll go away. Yeah? Because I did d divided by 3. Whatever's happening to the variable, if I have q times 6,742, to get that to go away, I would have to divide by 6,742 if there was an equation, if I wanted to get it by itself to find out what that is. So what that's saying is we can multiply both sides, we can divide both sides, just as long as we're keeping it on both sides, we will be able to solve for a variable and keep it mathematically accurate. So I introduced how we did it, and then I introduced why we did it. I could have done it other way around, and maybe that's how I'll do it in the future. But I like to see you guys figure something out, and then you find the actual reason for that. So I think it kind of rewards you, be like, all right, yeah, I could do that before I learned it. Yeah. Well, what is in blue for example 2? Multiplication. We multiplied both sides. We multiplied both sides. So in that situation, it would be if you A would equal d over 3, B would equal -3, and C was 3, if you want to make the connection to the algebraic, how we did that just now. If you wanted to evaluate these and plug it into that, that's how it works. That's what we just did. Okay? And you would come out with those numbers. D would be -9. All right. How? Because I don't use this thing. Why do I have it? So I can do this. And yeah. Oops.
No.
We're doing exponents. Doing exponents in pre-algebra. Okay, let's do this here. Wait, there's algebra in pre-algebra because it's introducing the concept of math science using variables. Let's do one more example. Yeah. Go ahead and do that one. See if you do or don't know how to do it. So go ahead and complete that one. Be sure to show every step. Every step you take, yeah. That's right. Yes.
If you want to donate some money, my dad could become a substitute teacher. What?
That has nothing to do with what we're doing.
Teaching degree.
So we have two.
Wait, if you're done, hold your writing utensil like this. You can just be right in front of you. You don't have to hold it up, just so I know who's done and who isn't.
My friend thing.
You want to do it on the board? Bert? Okay. I'm going to circle that. So yeah, negative 12 is P. That is correct. Now, if you wanted to check yourself so there's no wreckage, let's plug that back in. So I have negative 2. I have negative 2 is equal to, we just found that P is negative 12 over 6. Is negative 2 equal to negative 2? Yeah. I hope so, right? Okay. Do you want to see one more division property of equality? It's going to be so similar to the one we already did. Nobody said yes. It was only sure and no. And I will be happy to rewrite one, but I'm going to do the homework. Write down the homework first. I don't know why I wrote that down. So here's what we're doing. We are going to go out, down that way, through the main stairs. And I need to stop this video.